Mars is reborn in our minds with every new exploration journey. And in the 21st century, Mars is now the prime objective of planetary exploration. We are on the threshold of a series of missions searching for water and evidence of life forms, past or present, on planet Mars. And it all begins here. In the vast expanse of space, there is no other destination that can capture our imagination or reveal to us the mystery of human existence more than the red planet. These are exciting times for the pioneers of Mars exploration, and the memory of the future belongs to them, because today we are writing the first pages of the history of the future of planet Mars. The equation is simple. Water equals life. Millions of sunrises occur simultaneously just in the Orion arm of the Milky Way, and we still don't know if there's anyone else out there watching them. Is there life elsewhere in the universe? There is no need to search for the answer in a galaxy far, far away. We may find the answer as nearby as planet Mars. The discovery of life close to Earth will have significant implications for the meaning of our own existence and role in this giant universe. Because we will have discovered that we are not alone, and will have confirmed that life may be found anywhere.
It means maybe life is very common thing in the universe.
In this documentary, we want to open the door, even if ever so slightly, to the scientific reality of the exploration of Mars. And much like in a detective novel, we will try to uncover the clues that will help unravel the mysteries surrounding our perception of the red planet.
The exploration, I think, is the beautiful dream that we can give to the people.
It all begins with a point in the sky that, seen from Earth, glows fiery orange in the heavenly night. Mars, the red planet, has been a mysterious and terrifying world for human civilizations spanning millennia. But today, after centuries of the imagined world of Mars, we see its enormous volcanoes, its giant canyons, and its mysterious dry channels. Some of them ancient, while others seem to have been formed yesterday. However, water has been found on Mars, mostly in its polar regions. On Mars, there are 3 volcanoes with cones well over 15 kilometers high. Another volcano, Olympus Mons, has an elevation of 27 kilometers and is the highest known mountain in our solar system, 3 times the height of Mount Everest. It has been inactive as a volcano for thousands of years, and at its peak, the temperature varies from 5 degrees to minus 110 degrees Celsius. Here we are flying at low altitude and turning towards the 3 giant volcanoes in the Tharsis region. As we climb higher, we can see that they form part of a single huge volcanic uplift known as the Great Tharsis Dome. This topographical map was made by the Mars Global Surveyor. The peaks, shown in red and white, tower many kilometers above the deep basins, shown in blue, which at one time contained water.
The Tharsis Basin that I was talking about, we think that there might have been a large Europe-sized basin that contained water.
We know that long ago there was water on Mars and in the Tharsis region. But where has the water gone? This amazing 3D animation, shown for the first time on television, seeks to illustrate where the water may have come from on primitive Mars, where it went, and also where it might be hidden now. Today, early into the 21st century, finding life on Mars has become a priority.
There is one simple equation: water equals life.
Meanwhile, here on planet Earth, our discovery of life forms in conditions previously thought to be impossible are starting to bring to light a profound connection. If life forms can be found in extreme conditions on Earth, then why not on other planets?
We know now that organisms can exist almost anywhere there's energy available to exist.
To search for signs of water in order to find evidence of life. This is the main goal of the greatest concentration of space missions to the red planet in history. Presently, these missions consist of the Mars Express by the European Space Agency and the Mars Exploration Rovers by NASA.
In the United States and in Europe, there is a long program of working together, mission by mission by mission, to give us a composite picture of Mars, which by 2020, mankind will understand as much about Mars as we do about the Earth.
Gentry Lee has co-authored several science fiction bestsellers with Arthur C. Clarke. He worked with Carl Sagan in designing and developing the television series Cosmos. But he is also the chief of engineers of the unmanned planetary missions carried out by the legendary Jet Propulsion Laboratory in California.
I have an absolutely perfect job. My job is to make sure that anything that goes to another planet is engineered correctly and that the science and the engineering are in balance.
If there is a place or an organization in the world deeply committed to planetary exploration missions, it is undoubtedly the NASA affiliate, Jet Propulsion Laboratory. Apart from the Russian space missions and the current Mars Express of the European Space Agency, the Jet Propulsion Laboratory has designed and directed all of the unmanned missions to our solar system's planets. This is a very exciting time for explorers of the red planet. Just as it was at the end of the 19th century, Mars is once again at the center of planetary exploration.
In the 19th century, human beings began wondering what was out there. What were the planets all about? Were we alone? Were there other people somewhere? And of course, naturally, because of the historical bent of the Judeo-Christian society, most people wanted to believe that there were other human...
And surely they drew their plans against us.
Investigating Mars from Earth. Terrestrial analogs of the Mars surface. Indications of water flows. Canyons. Storms. Crater impacts. Volcanoes. Our vision of the red planet could currently be described as nouvelle vague or new wave. And the basis of this new wave means rethinking the Earth's geology in a new light in order to better understand Mars' geology. In other words, look for environments on Earth that might share analogous conditions with those of Mars.
One of the things that we try to do in studying Mars is look at the Earth to find areas that are like Mars so we can understand the data that we get from Mars.
And this is very important because Mars, in many ways, we can study more about this by comparing with terrestrial landforms. More we know about terrestrial, we have better understanding of planet Mars.
This idea has brought many planetary scientists to the island of Sicily, invited by the Italian Space Agency and the International Research School of Planetary Sciences.
In our name there is international, just because we think that we cannot separate different countries when we deal with planets. We are working on planets. It would be very stupid to say, okay, this is Italian, this is Spanish or Catalan or whatever. So we are international, and we try to attract people from all over the world.
Let's take a look at Mount Etna and its domain. Rising well beyond 3,300 meters above sea level, Mount Etna is the largest active volcano in Europe. Dominating northeastern Sicily, it has been present in all of the cultures that colonized the largest Mediterranean island. Continually smoking, Mount Etna has increased its activity over the last 50 years. The major eruption it experienced in 2001 created an immense cloud of dust that reached as far as Libya and the Sahara Desert. As we circle Mount Etna, the scenery is captivating. Gently rolling hills, wheat fields, and numerous signs of the interaction of the magma and the water.
And we're actually looking at some volcanic rocks, and then we see as progressively it becomes altered and transforming in this to Martian analog rock that we call pelagonite.
This is clearly visible in this stratum of rock, differentiated by its dark color on the bottom and much lighter color on top. This is the result of the catastrophic confluence of a river and a lava flow during one of Etna's eruptions.
This area here, we have real good evidence for the interaction of lavas with water, hyoclastics. But we also have Mount Etna, which is a large volcano that has been episodically active. We may see the same thing on Mars.
As we make the steep climb, the great volcano shows us its beautiful side. Our final destination is the southern slope of Mount Etna, at an altitude of 1,800 meters. One of the most spectacular missions undertaken by the Space Shuttle in the study of our planet involved making a series of topographical maps of the Earth's surface.
And we have an image here which represents the topography, or the 3 dimensions, of the area of northeast Sicily. And you can see very clearly Mount Etna in the center. And what this image shows is how high Mount Etna is and the 3-dimensional shape of it. We used 2 radar antennas that took the images at the same time, and then, sort of like your eyes, we're able to make the 3 dimensions from those images.
We can see how the lava flows from different eruptions overlap each other on the south side. The lava fields with vegetation are from the 1610 eruption, and they contrast heavily against the black lava flows from the 1985 eruption. The sun is setting majestically as we begin our descent. We pass a house buried in the lava, a foreshadow of what awaits us as we continue our ascension. These impressive satellite photos taken in July 2001 show the evolution in the column of smoke and ash, and in the fissures during the eruption. Over the span of 6 days, a 100-meter-tall volcanic cone was formed. Wind and black ash. The next day, Mount Etna receives us with a furious windstorm and a threatening dark sky. Our destination today is the Tazif cinder cone formed by the eruption in the summer of 2001 at an altitude of 2,800 meters. The going is slow as we lug our heavy equipment up the steep slope, battling against the fury of the wind that pounds fine volcanic ash against our faces. When we reach the top and gaze down into the crater, we realize it was worth the effort. Wind and red dust. The blood-red color and erratic trajectory of Mars in the night sky led our ancestors to identify the planet with war and chaos. But why is Mars red? Dust suspended in the atmosphere is a much more common occurrence on Mars than on Earth, and is the reason for the planet's most famous characteristic, the red color of the Martian sky.
If you looked at the sky on Mars, it would be red, not blue like here, and that's because of the dust that's suspended. And an important question for us in the past has been, how does that dust actually be removed from the surface and transported into the air? You had a breeze flowing along the surface. The air near the surface was rolling, and then if you have any kind of convection in that, then this thing will turn into a pair of dust devils with opposite vorticity. Martian dust devils are a very common phenomenon on the surface of Mars. When you think about Martian dust devils, you should think about tornadoes on this planet. These are enormous plumes of dust. Of the ones that we've studied, they average 3 kilometers in height, and they reach heights of up to 9.6 kilometers is the largest one that we've seen.
On the peak of Mount Etna, the black ash driven by the windstorm nearly destroyed our camera equipment in a matter of minutes. Even though the atmosphere on Mars is about 100 times less dense than the Earth's, the wind and red dust there can be much more lethal than here.
Dust devils provide a significant hazard to future exploration. Wind speeds of 200 kilometers per hour, it could pose a threat to a robot, for example. It might turn over your lander. An astronaut on the surface, they could pose a risk to the spacesuit, for example. The visor that you have could be frosted over in seconds, to the point where it would be impossible to see where to take the next step.
So, what was the Martian climate like in the ancient past? Was it hot and humid? Did it rain on Mars? For many scientists, the answer to these questions is crucial. Rain would imply a warmer climate, with water able to flow or form expanses for long periods of time, in order to provide a persistent water cycle that would allow for the existence of life forms. Many areas have been identified on the surface of Mars as having what appear to be ancient coastal lines. This suggests that during a long period of its history, Mars could have had oceans and lakes. Mars probably began as a warm climate with an abundance of liquid water. With the disappearance of water, perhaps a clue became fossilized that, if discovered, could solve the mystery of life on the planet. And this clue is quite possibly already in our midst. Around 3,600 million years ago, a flow of subsurface water deposited carbonate minerals on a bed of rock. Around 16 million years ago, a huge asteroid with an explosive power greater than 100,000 hydrogen bombs impacted against the Martian surface. As a result, a large portion of the planet was blasted out into space, and with it, a chunk of fossilized rock. During the Stone Age, when humans were beginning to cultivate the Earth, this meteorite fell to Earth and for 13,000 years remained buried in Antarctica until its discovery in 1984.
The most interesting of all of the Mars meteorites is the Allen Hills 84001, so-called, and this was found in 1984, thus the designation 84. Came to prominence in 1996 when a paper was published by McKay and Gibson, Thomas, and others, suggesting that there were 4 lines of evidence that this meteorite in fact contained evidence of early life, fossilized life from Mars.
Were they hints of life? One group of scientists say, oh yes. Another group of scientists say, oh no. We will not know for sure until we go back and find out.
7 years after NASA's declaration, however, what was the point of view held by the majority of the scientific community?
All of the scientists that I know, aside from a small group, who have looked at this meteorite, that the evidence of life in this meteorite is inconclusive, and we can't come to the conclusion that this represents an example of early life on Mars.
Regarding the possible presence of life forms in the Allen Hills 84001 meteorite, the majority of researchers maintain a healthy skepticism. Skepticism, as someone has said, is the chastity of the intellect and must not be discarded in favor of the first new idea that comes along. Extraordinary facts require extraordinary proofs. And in the ongoing debates on the possibility of life beyond Earth, what are most important are the proofs.
What this did do to the community is it really galvanized the community of which I'm a member. What does life look like at small scales in rocks?
The evidence for life forms in the Allen Hills 84001 Martian meteorite is not conclusive after all.
It galvanized the biological community to seek all kinds of different places where life could exist.
We presently have a much broader perspective of what we need to look for. And in some ways, this perspective has changed what we are going to discover on Mars when we finally arrive there. It will be a mission in search of evidence of life beyond our planet. But how do you carry out an exobiological mission to another planet?
If you want to set up a mission to search for traces of life, then the first question you need to address is, what is life? And what is life in terms of the mission?
There are some very imaginative ideas about what life is. Some are related to the Darwinian theory of evolution, reproduction, or our ability to swap genetic material.
All these definitions are extremely difficult to verify with an experiment on Mars. So we need a definition that is practical and easy to test. And if we look at what we know, which is life on Earth, then what we can say is that on Earth, life is cells. And so if we can find either living cells today or traces of cells, for example in fossil form, from previous times on Mars, then we will have accomplished our goal of establishing whether there is life or not.
The surface area of Mars is equal to that of all the continents on Earth. And thus finding evidence of life on Mars could be like finding a needle in a haystack. But first, we must find the haystack.
The search for life and the study of forms of life outside the Earth. As far as we know, as of today, on this planet, all over the solar system, there is one simple equation. Water equals life.
There are two things we can do to maximize the probability of finding life on Mars. One is to go to those areas that are known to contain water. The other is to go to places where once there was water and look for evidence of past life. Such places are easy to determine since there is a large network of outflow channels on Mars. But what might our relationship be to life on Mars or elsewhere in the universe? The answer may be found in the cosmic rain released from the tail of small comets containing water and organic material and traveling towards us from the far side of the universe. When meteorites left their imprint on the Earth, they may have also planted the seed of life. When a comet enters the Earth's atmosphere and begins to disintegrate, its fragments are sown over a wide expanse. The material from the meteorite's core is propelled by the wind and finally falls into our oceans.
What we're doing is we do research on organic molecules like polycyclic aromatic hydrocarbons and amino acids, what their behavior is on the Martian conditions. Right now I'm only looking at organics, which of course are basics for life. I don't want to give any conclusion yet of if there is life on Mars or not. Finding life on Mars would be terrific.
Where is the water on Mars? Our human perspective of Mars has gone through many different stages over the past centuries, but it has always been linked to water in one way or another. 18th century, William Herschel observed seasonal changes of the Martian polar caps. 19th century, Giovanni Schiaparelli saw straight lines on Mars as if forming canals or canali. 20th century, Percival Lowell went even further by stating that these canals conducted the water from the melting polar caps to the equator. 1898, in The War of the Worlds, H.G. Wells described superior forms of life looking at our blue planet with envious eyes. 1907, more skeptical, Alfred Russel Wallace described a frozen world with perpetual poles. 1930, a contradictory view by novelist Edgar Rice Burroughs described Mars as flowing with tonifying rivers. 1964, Mariner 4 photographs a desert full of craters and the entire world is hugely disappointed. 1972, Mariner 9 reveals a new Mars where water had truly flowed at some point in the past. But what role did water play in the evolution of the red planet?
The role of water. I think it's a very interesting subject because of the impact on the surface evolution and also the implication for life. I would choose water is one of the most profound unsolved questions on Mars.
Geological evidence suggests that water flowed on Mars a long time ago. Then something happened, and the planet's surface became a desert. But where did the water go?
Mars should have a lot of water. Geochemistry model how the Mars was formed at the beginning. And in fact, if you look at the surface of water, there's some water trapped into the polar caps. In general, the Mars surface is very, very dry. So this is a big question, and we are always looking for where the water goes.
In 2001, NASA's Mars Odyssey unveiled a clue to this enigma.
The Mars Odyssey was measuring a gamma ray and emitted from the hydrogen. And the presence of hydrogen probably implies that there are some H2O ice in the underground. It can measure water, I think, down to about 1 meter from the surface. And they found quite a lot closer to the polar regions.
The dark blue colors on this map produced by the Mars Odyssey indicate the presence of water ice in a large area near the southern polar region. However, we don't know how deep the ice lies below the surface, as we can only take measurements down to 1 meter below the surface.
But the fact we found a lot on the surface means probably there are plenty of ice in the ground of the Martian crust.
3,800 million years of Martian geological evolution. In order to explore the Martian ice caps deeper, we will have to study the data sent by the missions that have recently landed on Mars. Meanwhile, some useful clues on the whereabouts of Martian water are derived from different sources. This animation of the complex geological evolution of Mars reveals the existence of what could be an enormous water basin. Drawing from present geological and topographical data of Tharsis, a team of scientific researchers led by James Dome, who created the animation, have rewound the clock of geological activity 3,800 million years.
Tharsis was a large heat engine, extremely long-lived heat engine that was persistent for more than 3 billion years.
The variations in topography are enhanced to highlight differences. The colors represent altitude, with blue being the lowest elevation, brown representing the higher region, while the sharp mountain peaks are shown in yellow.
So here you have this heat engine that has large shield volcanoes, igneous plateaus, large canyon systems, but also it has basins that may have had water.
In order to understand the dramatic changes that took place, we can freeze the animation on 3 of its frames. Scene 1 represents the Martian surface more than 3,500 million years ago. It shows the huge volcanic bulge of Tharsis before the seismic pressure caused it to swell upward several thousand meters. Only a few mountains and hills surround the Tharsis basin, which may have contained great amounts of water. Scene 3 represents the end of the Noachian and beginning of the Hesperian periods. After the uplift, less than 3,000 million years ago, the Great Canyon of Valles Marineris began to form and the central plateau of Tharsis, called Thaumacia, began to rise. Scene 5 shows present-day Mars with an exaggerated topography. The central basin of Tharsis, which may still contain an aquifer, has risen and possibly forced the water outward. In spite of the excitement that this may produce, James Dome and his team caution that the animation is an illustrated working hypothesis that can be improved as our understanding of Mars increases. It's October 2002, and Mount Etna is erupting once again. Only 2 weeks earlier, we were near the volcano's summit, on the plain known as Piano della Concase. With an elevation of 2,800 meters, it is extremely cold and windy. The instruments and robots that will be used to explore the Martian surface will be put through strenuous tests right here. But why choose such a hazardous location?
But Etna is a very nice location, very good location, very similar to what should be the Martian terrains nearby the large volcanoes of Mars.
So now where are we? We're in the great time of Martian exploration.
the European Space Agency's Mars Express, traveling towards the Red Planet. The largest fleet of spacecraft ever sent to another planet has finally reached Mars after traveling 5.5 million kilometers. However, the optimism of previous Mars missions has been replaced by a deeper respect for the planet. It's a sobering thought when one considers that of the 30 earlier missions to Mars, 21 ended in failure. And of 12 landing attempts, only 4 were successful. Experience proves just how difficult it is to land on a distant world.
If you remember when Kennedy did the famous speech, we want to go to the moon by the end of the decade, because it's difficult to do that, because it's a challenge.
Spaceship to Mars. Mars Express Beagle 2. European Space Agency. Gian Ori and dozens of scientists from all over Europe have met the challenge of successfully getting the spaceship to its destination. This is the European Space Agency's first mission to Mars, the Mars Express. The purpose of the Mars Express is to study the planet's atmosphere, geology, and structure. But its primary goal, however, is to find evidence of water on the Martian surface and subsurface.
With Mars Express, we'll be able to penetrate, to look under the surface, down to a depth of a few kilometers, and if there is any water or water ice deposits, ice layers, or whatever, we'll be able to detect them.
The spacecraft is actually two, an orbiter and a probe that must land on the surface and unfold its sensors. The lander is named Beagle 2. Its mission is to photograph its surroundings and use its robotized arm to analyze rocks and soil in search of organic material, water, and minerals. It seems, however, that the lander may have been lost or damaged, since so far it has been impossible to make contact with it.
Beagle will go in a preliminary way, make geological, mineralogical, geochemical analysis, and also a few analyses in order to detect possible forms of life.
The high-resolution images sent back by the Mars Global Surveyor have revealed a never-before-imagined view of Mars. Images of some of the most astonishing and beautiful sights in the solar system. Near the South Pole, the strong winds carve sculptures out of the frozen areas, creating shapes unlike any ever seen in other worlds. These new and fascinating images have intrigued the scientific community about what might lie beneath the ice. These curious terrace-like layers of ice and dust or volcanic ash could contain evidence of Martian conditions and climate, just like tree rings do. These gullies seem to show signs of recent liquid water erosion. The surveyor has identified over 200 sites where the erosion-scarred gullies look as though they were formed yesterday. The Mars Express orbiter is equipped with an enhanced high-resolution stereo camera.
With Mars Express, you will have a large image, and inside you will have, knowing exactly the coordinates, the high-resolution image. So you will be able to make correlation between the geological or morphological structure at large scale with small-scale morphological structure, which is extremely important.
By mapping and studying the Martian surface, we will gain understanding of its mineral composition, identify the composition of the atmosphere, and carefully measure its behavior and interaction with the planet's surface. All this new data will be collected using 3 instruments: the high-resolution stereo camera, the Marsis radar sounder for probing the Martian subsurface, and the Omega sensor.
These 3 instruments will provide the first complete data set, by far better than any other mission that flew to Mars.
The International Research School of Planetary Sciences will be waiting for this data rather impatiently.
What we are doing now is to try to take full advantage of the European mission Mars Express. That is a great chance for the European community, scientific community. We'll work on the analysis and processing of the Mars Express geoscientific data.
Spacecraft on Mars, Spirit and Opportunity, NASA. NASA has returned to explore the surface of Mars not with one, but with two all-terrain vehicles. Named Spirit and Opportunity, these exceedingly capable remote-controlled geologists are fully equipped to search for and locate water.
There's a PanCam, which is essentially a multispectral stereo imaging system. There's a mini thermal emission spectrometer, which allows us to do some compositional stuff remotely. There's a rock abrasion tool down low, which can scrape off the surface of rocks to get through the weathering rind and see the fresh surface. There's a microscopic imager that allows us to see very detailed information about the textures of rock. And there's a couple of other instruments, an X-ray spectrometer, as well as a Mossbauer, which tells you something about the iron mineralogy. And it's that suite of instruments that allows you to land on the surface and say something about the role that water played.
But these rovers won't be able to discover anything about the history of water on Mars if we send them to the wrong place. Choosing the appropriate landing site is critical. It also opens up many topics for debate. Safety.
We have to be sure that both rovers land safely. And for that to occur, we have to understand the sites very well and understand the potential hazards that may be there.
Or science.
The second is the science of the site. It's only second because if you don't land safely, you don't get any science. So science is a little bit behind the safety.
Finally, after years of debates and after considering a plethora of Martian sites, the Spirit and the Opportunity landed on the two different sites near the Martian equator, but on opposite sides of the planet. This is Gusev Crater, where Spirit landed. And here we see Meridiani Planum, where Opportunity set down. The Mars Express Beagle 2 descended on Isidis Planitia, although all communication with the probe was lost. Over a period of 90 to 100 days, the rovers will travel up to 1 kilometer from their landing site.
So this is a whole new era of Mars exploration. I mean, literally we have a field geologist on the surface that is able to move. It's not locked in one location. And I think that is what's really exciting. It's the combination of mobility and science that allows us to really make that next step in understanding Mars as a planet.
Stories of the future of Mars. NASA's ambitious plans for Mars in the future will make maximum use of every opportunity and resource. 2005, a reconnaissance orbiter mission. 2007, a scientific scout lander mission. For the first time, scientists rather than engineers are deciding what is the mission's primary objective. Several options are being considered. An orbiter, perhaps a small lander, an aeroplane, a glider, or a balloon. The competition is underway. 2009, a surface exploratory mission with the nuclear-fueled Mars Space Laboratory rover. The rover would explore the Martian surface over the span of 1,000 days. This mission will take us to the ultimate goal of the Mars program.
Every scientist that I have talked to forever has said, you must bring a sample back from Mars and let us analyze it in our laboratories, and then we will paint the portrait of Mars.
Europe salutes the new millennium with a series of missions whose ultimate purpose is to send a European astronaut to Mars by the year 2030. This is the Aurora program. The first mission will be to perform exobiological research. Named ExoMars, the mission will explore the Martian surface using a variety of scientific instruments, its primary tasks being to find water and evidence of microorganisms. The next goal will be to master and complete 3 essential operations on a manned mission: the outbound flight, concluding with a precision soft landing; the return flight, beginning with liftoff from Mars and orbiting the planet; and then a safe re-entry into the Earth's atmosphere. Prior to such a manned flight, these 3 elements will be combined and tested in a complex mission called sample return. It is so complex that 5 different types of spacecraft will be needed to carry it out. This mission will return Mars surface samples back to Earth. The technological complexity of such a mission is overshadowed by the magnitude of its scientific value and impact.
This is a miniaturized human mission to Mars. All the elements are there, and at the same time, if we bring back Martian rocks, I think it will be the biggest prize we can give to the planetological community on Earth.
The astronauts who will explore Mars may possibly discover yet another mystery buried beneath its surface, much like a message in a bottle thrown out by a castaway into the endless ocean of space. A compact disc traveled aboard the Russian spaceship Mars 96 that crashed on planet Mars. The CD contained a message to the future inhabitants of Mars. My name is Carl Sagan. Perhaps you are presently on Mars thanks to the efforts of science and to the wonderful doors that were opened in our time. For whatever reason you are on Mars, I'm glad that you made it there, and I wish I was there with you too. Perhaps we have cracked open the door for you to a whole new world, Mars. Although this documentary ends with more questions than answers, something that occurs quite frequently in most scientific endeavors. After all, science is merely the Latin word for knowledge.
Science is like philosophy or like literature.
The era that will see Mars reveal its mysteries is closing in on us at full speed. But the truly significant mystery is that the more we learn about Mars, the more we learn about the universe.
There are 2 fundamental questions about our existence which are behind the exploration of Mars. Number 1 is, are we alone? And number 2 is, where do we fit in this great universe of ours? Exploring Mars is the first big step to answer both those questions.
Will we find irrefutable proof of whether or not we are alone in the universe? Will the day come when we can say, confirmed, life on Mars? What an exciting time to be an inhabitant of this beautiful pale blue dot.